Okay, hey back, hey back. That's not an introduction. Hello everyone. So we're continuing from wherever we left. We left at 2.4 functions. So this is a very interesting part of the chapter because this is the place where things start to get tricky and interesting as well. So what is a function and how do you define a function? We'll probably take some examples so that it is very easy for you to understand, and we'll start with the notations, how functions are represented. So a function could be written in the small letters of English alphabets, A, B, C, D, E, F, G, whatever you want to write it, and the way you have the notations between two relations is that it's written as F, alright, then semicolon, then whatever your set name you have for the input, and it is marked with an arrow, then to whatever it is related. So generally it's like X is related to Y, or F is a function from X to Y. So Y is called as the image of X and X is called the pre-image of Y, or Y is called as the dependent of X and X is called as the independent variable. Why? Because X does not have to depend on something. X is the input value and then you put it into some function, for example 4x plus 3, and the output is given to whatever the equation is there. For example, y is equal to 4x plus 3, so y would be the output here, and that's why y is equal to 4x plus 3, whatever x you put in, it will come into y. So y is the dependent variable of x and x is the independent variable. Alright, that's all about the notations. Now we will look into the various examples, which relation is a function and which relation is not. So let's start with this. The example that they have taken is really great. I liked it. And for example, let's say X is a set of daughters, Y is a set of mothers. So now why do we call this relation a function? Because every daughter, now related to the real life scenario, every daughter should have a mother, correct? So x1 being a daughter has a mother y1, x2 being a daughter has a mother y2, x3 being a daughter has a mother y3. Now the y4 element, that's mother number y4, does not have a daughter, and that is okay because you do not have to be having a daughter to be a mother. You could have one son, two sons, three sons without a daughter, you could still be a mother. Alright, and now all the elements x1, x2, x3 are called as the domain of x, alright, of the function, and y1, y2, y3, y4, all the elements in y are called as the codomain of the function, and whatever elements have been mapped are called as the range of the function. So let's take another example. Now relate to this, x1 being a daughter and these being the mothers. So a daughter is coming from two mothers, y1, y2. I think that's not possible on earth, probably on Mars that might be possible. So if you consider that scenario, it is not possible to have this relation, and therefore in the very first case you can reject this particular relation to be termed as a function, because a daughter cannot have two mothers. And x2, though x2 has one mother, that's okay, but since x1, there's a problem with x1, we cannot consider this as a function. Then comes the third example, x1, one daughter, one mother, one daughter, one mother, one daughter, no mother. That's not possible. I think Jesus has already gone. We do not have any those kind of gifts given by Jesus now anymore, so that's also not possible. So if there is no mother, there cannot be a daughter from nowhere. So this is also not a function. Now let's go to another example. I think all these four scenarios cover everything of whatever you want to know about functions. Next scenario is like one daughter, one mother, okay. One daughter from the same mother, that's absolutely fine. A mother can have two daughters. Then another daughter from some other mother. Oh, too much other mother, that's rhyming, oh my god. Alright, so x1, x2, x3, daughters, mothers, that's absolutely fine. Another mother, no daughter, another mother, no daughter, that's absolutely fine. So what can we conclude out of this is that every element in the input set should and should have an element in the corresponding relation to the set Y, okay, and it has to be it can be non-unique. For example, if you consider this, these two things have a non-unique element in Y. Every daughter can come from the same mother. If you have 3 daughters, you can come from the same mother. If the mother has too much time, she can produce as many kids she wants. I think there's a record for this. There's someone out there who's produced more than 27 kids, if I'm not wrong. Alright, so every element in X can have an element in Y, and two different elements can have a same mapping element in Y, but a same element cannot have two different elements in Y. A daughter cannot have two mothers. Two different daughters can have the same mother. Alright, now what's the next condition? Next condition is that even if there are some elements in the set Y, if they're not mapped to anything in the set X, that's absolutely fine. A mother cannot have a daughter, or she might have a son. So you remember what a domain is, what a codomain is, what range is. These are the domains, these are the codomains and ranges Y1 and Y2. Some more concepts we'll take up in the next video. Till then, keep watching, keep sharing, and do put in the comments and let me know if you want to know something else, or probably you have some questions. People will help you out there. Till then, bye bye.